Okay, welcome back to our part 2 of the rung length encoding, which is lesson number 9. Now, I hope your brains aren't too fried. We'll try and work out what number was in that sequence. But the answer is as follows. So 0, 1, 0, 1, 1, 1, 0, 3, 1, 1, 0. The answer is 1, 3, 2, 1, 1, 0. Now, you're probably thinking, what's he going on about? Well, once I tell you what the idea is, it'll make sense. So we start off with the number 0. Now, what this number here is it's telling me that there's 1, 0. Okay, the next number in the sequence. So we've got 1, 2, so 1, 1, 1, 0. So what this means is we've got 3 1s and 1 0. So the missing number would be, so we've got 1, 3. We've got 2 1s and 1 0. Okay, so 1, 3, 2, 1, 1, 0 is the number, the missing number in the sequence. Yeah, so what? So as I've just explained, the numbers obviously describes the previous one. Now this is similar to what's called run length encoding, where we group data that's the same next to each other. Now, for example, if we have a look at this here, we've got 6 A's and we've got 3 B's. So we would class this as 6A, 3B, okay, which is only 4 characters instead of 9. Yeah, okay, so what? Well, as soon as we're talking about compression, you can see that straight away. Instead of having something which is 9 characters, or let's say 9 bits, we can transform it down into 6 bits. Okay, so straight away you can see the links to our previous lesson about compression. Now, just another reminder. Okay, so bitmap images are made up of pixels, and each black or white pixel is 1 bit. So in this example, we've got 7 pixels or 7 boxes across and 6 pixels or 6 boxes down. So 7 multiplied by 6, which means that there's 42 bits in total, which makes it a 42-bit image. So if we take that to the next step, okay, so we've got our image here. Now we've got, so it's 2, 4, 6, 7, 2, 4, 6. Okay, so we've still got a 42-bit image here. Now, for this example, or for the tasks in this lesson, instead of using 1 and 0, we're just going to use W for white, B for black. Okay, because it's going to be simpler to complete the tasks. Now, we've got our image here. Now, if we use W's and B's to describe this image, okay, this is the code that we would get. Now, we've already discussed something before, but is a way of writing this code without having to write W or B's or 0 or 1s 42 times. Okay, put your answer in this box here. Okay, once you've done that, then obviously we can move on. Okay, so hopefully you would remember what I mentioned in on slide number 2 about making things big, or rather beginning, making the codes smaller instead of writing out 42 W's and B's all the time. Now, this takes the idea a step forward, so compressing the code. So if we have a look at the first line of our image, okay, so we've got 7 W's. Now, what we can do is we can compress that code and just say we've got 7 W's. Okay, so instead of having 7 bits for our first line of our image, we can narrow it down or cut it down to 2 bits. Same with the next line of code. We've got 7Bs, so we've got 7Bs, and we can compress that to 7B. Okay. Same with the third line of the image. We can still say 7B. Now, what's interesting here is we've got 1 white bit, 2, 4, 5 black bits, and 1 white bit as well. So we can rename that as 1 white, 5 Bs, and 1 white. Okay. So we've compressed it from 7 bits to 6. Similar to the next line of the image, 2 whites, 3 blacks, and 3 whites. So we dropped another bit there. And obviously the same situation with the last line. Okay, so you can see straight away how we can make our images smaller through this method. So instead of having 42 bits for our image, we can compress it down to 24 bits. Obviously, when we decompress it, we get back to our original image. Okay. Now, run length encoding. Now, what we've just talked about is the definition of run length encoding. Okay, so you count how many pixels or how many W's or B's or 1s and 0s, and then we cut it down to 7 W's, just like we talked about before. Okay, so by using the run length encoding, we can make the file size smaller, and then obviously when we decompress it, it'll go back to our original image. All right, so something new for you to think about. Now, to test your understanding of this, you've got several pictures on the next slides, and what you need to do is to compress the image to run length encoding, starting by converting image to B or W code and then compressing this. So what do I mean? Well, this is the image 1, so we can do this one together. So we've got the image here, which we have to reproduce using W's and B's. So because we've got all white pixels at the top, then we will type in all W's for the top. Okay, same for the next line. Now, obviously, to make it clearer, the next line, we've got 2 whites, 4 black, and 2 whites. Okay, I'm not going to finish it all off because you should be able to understand where we're going with this. So in this box here, you're going to write the run length code. So we've said we've got 8 W's here, so we type in 8 W's. Same for the second line, and then the third line we have 2 W's, 4 B's, and 2 W's again. Okay, so you've got several different images for you to complete. I won't spoil the fun, so that's what you need to do. Let me take these out for you. Okay, so back to normal. Now, once you've done all these images, you can make your own 2 images. So think of an image that you want to create. Obviously, use the B's and the W's in the boxes, and then show me what the run length encoded version is. You've got 2 opportunities to create your images here. Okay, so pause the video, go and complete the slides, and then as soon as you've finished that, then you can complete the plenary task. Okay, welcome back. So this is the last part of the lesson. So to test what you've understood and what you've learned in this lesson, I'd like you to match the run length code to the image. So obviously look at the code and match it with the images on the right. Use the arrow tool to obviously draw the lines to those. Now, that's the end of the lesson. So hopefully you'll have understood what run length encoding is. You've decoded or you've compressed images down to B's and W's and then use run length encoding to compress the image even further. Okay, so thanks for watching. I hope you enjoyed the lesson and I'll see you next time.